My name is Kanchan Waikar, and today I will show you how to deploy a machine learning model from AWS Marketplace using Amazon SageMaker. A machine learning model accepts a payload and it returns you a prediction. AWS Marketplace contains over 200 machine learning models which you can deploy either using code or via AWS console. If you wish to deploy the machine learning model via console, I recommend you to see this blog and follow the instructions to give it a try. But for today's demo, I am going to use a Jupyter notebook to deploy and perform inference on a machine learning model package from AWS Marketplace. And the first step is to create a notebook instance. So you can see I've logged into my AWS account and I've selected notebook instances from the left panel. Then to create a notebook instance, I need to click on Create Notebook Instance button, specify notebook name, and then choose Create Notebook Instance. I will be using this notebook instance to write code for deploying and performing inference on machine learning model package from AWS Marketplace. Okay, so let us get started. Let us see how to explore model packages from AWS Marketplace. Well, there are two ways to do so. Either you can select model packages from the left panel of the SageMaker console, and you can search for the model you're looking for here, or you can go to AWS Marketplace, choose delivery method as Amazon SageMaker, and then select resource type as model package, and then look for the machine learning model you wish to try. For my today's demo, I'm going to deploy and perform inference on Gluon CV object detector model package. So I've clicked on the link and you will see that it shows you a product overview over here, and it provides you additional information about the listing under the highlights section. If you scroll down, you will see two types of pricing associated with a model package from AWS Marketplace. One is a software pricing, and second one is the infrastructure pricing. Infrastructure pricing is a pricing applied by Amazon SageMaker itself, whereas software pricing is the price which is being set by the seller who has listed their machine learning model packages in AWS Marketplace. You can see that this particular ML model package does not have a software pricing associated with it. That is, it is free. Many models are free, whereas some models are paid. And for a paid model, you would also be able to find out whether is there any free trial associated with it or not. And remember, the software pricing as well as hardware pricing may vary based on the instance type on which you perform inference. You can find information about how to use a model package under fulfillment method section. Typically, you require two things. One is the content type, and second is the payload itself, the format of the payload that is accepted by the model itself. You can see that this particular model accepts an image as a payload, and these are some of the content types that are supported by this particular model. You can also find additional information under additional resources section, and you can find the support information under the support information section of a listing. Next, you can click on continue to subscribe. To be able to subscribe to a machine learning model package, your IAM role needs to have marketplace related IAM permissions. And these are the three permissions which you typically require. And also, to successfully deploy and perform inference, you would also need an IAM execution role with appropriate IAM permissions configured. Typically, Amazon SageMaker Full Access works very well. I'm going to go back to my notebook instances and see if my notebook instance is now available. You can see that the status of my notebook instance is in service, which means I can now use this notebook instance for running my experiment. So I'm going to click on this Open Jupyter link. And you would notice that it opens the Jupyter console. And to make it easy, AWS has provided you some sample code which you can get started with. So go to SageMaker Examples tab, and under AWS Marketplace, you will notice this sample Jupyter notebook which you can use in order to deploy and perform inference. So you need to click on the button called Use and then click on the Create Copy button in order to create a copy of that sample Jupyter notebook. A sample Jupyter notebook typically contains code as well as some instructions which you can follow in order to deploy and perform inference. You can see that there are some prerequisites written over here, and under additional resources section there are some links to the documentation pages, blog post as well as other webinars and sample Jupyter notebooks. Feel free to refer them as required. And at the table of contents, you can see that there are these 5 major steps that you need to do. First, you need to subscribe to the model package. Then, if you want to perform a real-time inference, you want to create an endpoint. And once you have created an Amazon SageMaker endpoint, you would perform inference and then you would delete the endpoint in order to avoid getting charged. Because remember, a marketplace model package has software pricing as well as hardware pricing, and as long as the endpoint is up and running, your account gets charged for it. And then there is a batch inference that you can perform as well. A batch inference typically stands up the model, performs inference using the payload that you have specified, provides you the output, and undeploys the model. And there is and of course, batch transform and batch transform job also has software as well as hardware pricing associated. Although in this particular model's case, the software pricing is 0. Okay, so let's follow the instructions written in this particular notebook. You can execute the code written in the notebook by pressing Shift Enter. So I'm going to press Shift Enter for this cell, and you will see that there was a star mark appeared in between these two brackets briefly. It means that the code in that particular cell was executing. And now it has executed successfully, which is why we see a number 1 over here. This is the bucket. This is the S3 bucket I'm going to use for storing my data. The next step is to subscribe to the model package. You can see that this section mentions that you should open the listing, you should read the information carefully, and then you should read the pricing information carefully for both real-time inference as well as batch transform usage. And then you should note the vendor recommended instance type. So I'm going to go back to the listing, and you'll see that there is a vendor recommended instance type specified here. And in this particular model's case, it is ml.m4.xlarge. So I've copied ml.m4.xlarge from here. And the instructions asks me to specify the same over here. Similarly, I would do the same thing for batch transform as well. And for batch transform, ml.m4.xlarge is the vendor recommended instance type as well. So I'm going to specify this, and then I'm going to press Shift Enter in order to run this particular code. The next step is to actually identify the content type. Each machine learning model accepts a specific type of content type, and this information is typically available on the listing itself. So you can see if I scroll down, you'll be able to find that the content types supported by this model are image slash JPEG, image slash PNG, and image slash BMP. In this case, I'm going to specify image slash PNG because I have a PNG image on which I would like to perform an inference. So I'm going to specify image slash PNG over here, and then I'm going to run this cell. But let me take a quick pause and also tell you the ways of identifying the content type. So in the case of our model, content type was specified very clearly. However, there are some other models for which content type is not very clear. For example, let me open this particular listing, and you would see that the content type is specified as application slash JSON. So if you're trying out this model, you would specify application slash JSON as the content type. And then for the vehicle damage inspection listing, you would notice that the content type is not explicitly provided over here. However, there is a usage notebook folder present over here. And if you download the usage notebook folder, you'll be able to find a sample notebook. You can then upload the sample notebook over here and then open the sample notebook in order to see if a content type has been specified in the sample notebook itself. And in this case, you'll notice that there is an invoke API endpoint call that is being made from the sample Jupyter notebook for this particular listing, and it clearly calls out the content type as image slash JPEG. Similarly, there is another, there could be other models for which you may have to find out content type from the information available either in usage and in the usage information section or in the additional resources section. And then once you have figured out the content type, specify the same over here and then run the cell. The next step is to identify the model package ARN. A model package ARN is a unique identifier for each machine learning model package from AWS Marketplace. So it says that you go back to the listing and click on continue to subscribe button. So I'm going to click on continue to subscribe button. And then next, on subscribe to the software page, it asks you to review the EULA support terms pricing information, and if you and your organization agrees with the same, accept offer button needs to be clicked. In this case, I've already taken the liberty of clicking the accept offer button, which is why it shows already subscribed. And then the next step is to click on continue to configuration. So in my case, continue to configuration button is active, so I'm going to click on that. And then we need to choose the region in which we would like to deploy the machine learning model. So you can see that I am currently in Ireland region. So under configuration, under region, I'm going to choose Ireland as a region. And this is the product ARN, which is basically a model package ARN, which I need to copy. So I've copied the model package ARN and I need to specify this here. And then I need to execute the cell. So great. So far we have identified all the necessary information to be able to create an endpoint and perform a real-time inference on this particular model. So the next step that you need to do is to actually stand up an Amazon SageMaker endpoint. But for that, you would first need to think of an endpoint name, and that's what I'm going to specify here. So I would like to call my endpoint as Gluon CV, and then I'm going to press Shift Enter in order to execute this cell. Now I need to create an endpoint. So I'm going to execute the code of this cell without changing anything, and then you would notice that my endpoints starts getting deployed. So if I go to Amazon SageMaker and if I go to endpoints, you would notice a new entry appear over here with the same name that you specified in the sample Jupyter notebook. And you would notice that the status is specified here as creating. This may take a couple of minutes. You can see that the star mark present in between the square brackets here has gone, and the number 7 has appeared, which means that this particular code has executed. You would also notice that an exclamatory mark has appeared over here. This means that our endpoint is in service and now we'll be able to perform inference on it. Remember, as soon as the endpoint becomes in service, your AWS account starts getting charged for the endpoint that you have deployed. And with marketplace listings, there is a software charge as well as hardware charge. So remember to turn it off as soon as you're done. And deleting an endpoint is super easy. Just select the endpoint from the console and select actions and then delete. And that would delete the endpoint. But let's get back to our demo now, because the purpose of this demo is to really show you how to deploy an endpoint, and once an endpoint has been deployed, how to perform inference on top of the endpoint. So the first step that we need to do is to create an input payload. Each machine learning model package accepts a payload in a very specific format. You'll notice that this particular model package accepts the payload in a very simple format, that is image/jpeg, image/png, or a BMP file. However, there are certain model packages which require input to be formatted in a specific format. And typically, this information will be available under additional resources or under usage information section. So let me show you this particular listing. You'll see that this is another machine learning model package for which the input format itself is an application/PDF, right? And you'll also notice that under additional resources section, there are sample input files available over here. So you can, feel free to choose the files available in additional resources to, give it a try. But in this case, the model package that I'm trying to perform inference on, it does not has any sample input file. However, since the format is very simple, I don't really need a sample input file for trying out this particular model. I'm going to use something which I have of my own. So you'll see that there is some sample code available over here, which you can potentially reuse if you want to download the file from the internet. But in this case, I don't have a file which I need to download. So what I'm going to do is I'm just going to upload the file that I want to use. So I'm going to go to the Home tab, and my notebook is under this folder. So I'm going to navigate inside the folder, and then I'm going to upload the image that I want to use. So this is the image that I've chosen, and I'm going to click on the upload button now. So you can see that this is an image of a truck and a construction machinery. And I am going to perform inference on this particular image. So I'm going to copy the name of this particular image, and that is img.jpg. And then I'm going to go back to my sample notebook, and I'm going to specify the file name as img.jpeg. Since I don't need to download the file from the internet, I don't need to execute this particular code. But if I were to use a file from the internet for performing inference, then I would have specified a URL over here, and then I would have specified a file name over here, and then I would have specified a file name, and then I would have downloaded the file by executing this particular piece of code. Sometimes the files are provided in a zip format, which is why this additional piece of code has been provided to you in order to unzip the file that you downloaded. And once you do that, identify the correct name of the file, and you would need to update the file name variable over here. Now I need to view the file which I need to use for performing inference. So you can see that by uncommenting this line of code, I was able to see the image which I'm going to use in form of a payload for performing inference. Sometimes there are certain models which require very specialized input formats such as application/JSON, and typically the payload that you need to provide to is typically an image or something like that. At that time you might have to do certain kind of pre-processing. For example, the background noise classifier, which is an audio model, it accepts audio data. However, it accepts the data in form of a JSON. So you can see how this particular model requires you to take the audio file, convert it into base64 encoded format, and then create a JSON like this before you can send it. So you'll also notice that many of these listings have certain additional pre-processing code that they might provide in this particular section as well. Yeah, and here is just some sample code which does base64 encoding. If you want to, if the model you want to try requires base64 encoding, feel free to reuse this code. But remember, the payload variable that you ultimately create, it needs to have the format that is applicable for the model that you wish to use. And then once you have identified the payload, you would typically write it to an output file. So feel free to uncomment this particular piece of code in order to write the payload that you created to a file. But in our case, our payload is very simple. It is just an image which I want to provide to my machine learning model. So I can literally skip this entire section, B.1, the pre-processing section. So I'm going to go to section C, and I'm going to perform real-time inference. So you would notice that for real-time inference, I have to now specify the output type as well over here. So if I go back to the listing, you'll see that the output is available in a very plain text format, right? So what I'm going to do is I'm just going to specify the output as output, and then I'm going to press Shift Enter in order to specify that the output of my inference should be written to a file name called output. And then I'm going to execute this particular piece of code in order to perform inference. You notice that I ran into an issue because the region was specified as US East 1 over here. So this is something which I need to fix. I need to specify appropriate region over here. In this case, it is US West 1. So I'm just going to quickly edit this to US West 1, and then I'm going to press Shift Enter. So you would notice that the machine learning model was able to accept my payload, which was an image of a truck and a construction machinery, and it was able to perform an inference. When you see an output such as this, it means that the model was able to successfully perform an inference. If you don't see output such as this, then go ahead and try to identify why the model was not able to perform inference. There could be an issue in the payload itself, or there could be an issue in the content type accepted by your model. And then, now that I know that the inference was successful, I am going to write. I'm going to actually read and see the output that was returned by the model itself. And you can see that the model returned these two entries, it found two vehicles in the picture. The one on the left was identified as a truck with a very high possible probability, and the one on the right was identified as a truck but with a very low probability. And in order to prevent your account getting charged further for the endpoint that you created, don't forget to delete the endpoint itself. And there are two ways to do that. Either you can do it via console, or you can do it via code. So in this case, I'm going to simply execute this code in order to delete the endpoint. The next step is to perform a batch inference. So in order to perform inference on model, there are two ways. One is real-time inference, which we just performed. The second option is to perform a batch inference. And this comes in handy if you have a lot of data points for which you would like to perform inference for on a regular basis. So what I'm going to do is I'm going to use the same payload that I used for performing real-time inference, and I'm going to perform a batch inference. So I'm going to execute, this particular piece of code. It is going to take the same file that was specified, that was used as a payload for real-time inference, and it is uploading it to S3. And then I've started a batch transform job for performing the batch inference. You can see that the batch transform job has finished successfully, and the star has changed over here to number 16. So now I'm going to analyze the output that was returned by the batch transform job as well. So I'm going to execute this line and this line, and you'll see that the output returned by the batch transform job itself was pretty much identical to what we got from the real-time inference. Now that the model is not required anymore, I'm going to delete the model itself. So great. So you have successfully deployed a machine learning model from AWS Marketplace. You have performed both real-time inference as well as batch transform job for performing batch inference on this particular model. And you have also cleaned up the model itself from your AWS account. Okay, so as a last tip, I'm going to recommend you to often check whether you don't have any endpoints that are deployed that you are unaware of. And also, once you are done, save your work, download the file notebook, or just save it in your notebook instance, and switch off your notebook instance, because your notebook instance also gets charged. So for switching off the notebook instance, I recommend you to select the notebook instance and then select stop under actions. And that's it, guys. This was a quick overview of how to deploy a machine learning model from AWS Marketplace.